Hey guys, thank you so much for joining us today. Today's panel is about audio design for mixed reality application, and I have to say the whole industry is only at the beginning of an extraordinary journey, and it's really exciting time for us to be here, to be part of it and talk about it. So let's introduce ourselves. My name is Oliver Kadel, and I'm a co-founder and audio lead at 160 Digital, and I also co-present Immersive Audio Podcast. From left to right, Jean-Marc, a distinguished fellow at Magic Leap, Jacuzzi, a 3D software engineer at Sennheiser AMBEO innovation team, Orfeas Boteas, founder and CEO at Krotos, and Gerrard is an AR developer and a head of sound at One Rick. So we're going to dive into this topic right away, but during the last segment we're going to maybe allocate 15-20 minutes and open up the floor for Q&A. Okay, so let's begin. Guys, could you please introduce yourself and tell us a little bit more about yourselves, what you do, and I would like to start with the first question. What does audio design for mixed reality mean to you today? Let's have a Jean-Marc.
Okay, I'm going to start. I'm Jean-Marc. What I do is I lead a team that we call the Audio Algorithms team at Magic Leap. That was founded about the beginning of 2018. And we essentially, the purpose of it is to populate, be responsible for all the audio algorithm, all the audio processing in the device. Right now we are focusing on 3D audio rendering. That's all that's good for you? Okay.
Thank you.
Hey everyone, thanks so much for coming. So my name is Jacuzzi, and I'm a 3D audio engineer and experience designer for Sennheiser's AMBEO team. AMBEO is kind of the company's umbrella term for everything we do in the world of immersive or quote-unquote 3D audio. And my role in a lot of projects is to be kind of the person that makes sure our audio solutions are working with real applications or experiences. So lately, like the latest project that I've been involved on is an experience we made for Magic Leap, actually, called the AMBEO Augmented Audio Lab. Which is just a glimpse at what might be possible when we think about designing mixed reality experiences specifically with the audio in mind. So that's been kind of my role, just making sure that our audio tools are working well in that space and trying to see what can be done moving onwards.
So yeah, it's great to be here. So I'm the founder of Krotos. Krotos is a company that develops audio software for the entertainment industry. So our mission is to improve the way people work with sound. We started by making Dehumanizer, which is software for making extreme vocal effects with your voice. And we have a whole suite of different tools now and different technologies. And in terms of new media and mixed reality, we have this software called Reformer, which allows you to perform sound effects in real time. And you can also generate them from data. So we're interested in kind of exploring this more, and kind of we're interested to see how you can improve the way you design and perform sound effects, and how real and virtual objects can interact and create sound effects in real time. So it's kind of what we do.
Hello, I'm Gerrard, and I am the head of sound and an AR developer for One Rick Studios. We're a content-driven AR studio specifically. We're pretty bound to that medium. And as head of sound, I'm in charge of everything from music to sound design to dialogue editing, and I work with a few of the other panelist tools to assure the most quality product at the end. And I think spatial sound is like evolving to be, even more important to the medium than sound is for films, just to dealing with things like presence. Yeah.
Thank you. So mixed reality in its sort of most current shape and form as a term, it's relatively new, and perhaps our audience here and the wider audience online are more familiar with the term virtual reality. So what we'd like to do is ask Jean-Marc, could you please explain the key differences between virtual reality and mixed reality?
Sure. So virtual reality is relatively recent as well. And you may have, there are a number of devices already to play virtual reality, and that's been an exciting field. But fundamentally, what it's trying to do is immerse you in an experience that replaces your real world. So forget your real world, and we're trying to suspend your disbelief. You put all that gear on your face, make you feel like you're somewhere else. You're aware it's artificial, that everything you see and experience here is artificial. In mixed reality, you also wear a device, but you see the real world at the same time, and you hear the real world at the same time. So most of what you're experiencing is real. And that's very different because now the device allows you to, renders graphically and also audibly some additional pieces of information, some objects, some characters that you might see. But ideally, if it all works perfectly, you might not know what's real and what's virtual, contrary to virtual reality. So that creates for us, it's a new step in the challenge of rendering virtual objects because we have the challenge of matching reality, and you can compare in real time the real world and the virtual world in those situations. So that's why it's exciting to us.
Guys, would you like to add anything on this one?
Yeah, I think that, touching on what you said, I think in augmented reality specifically, like this idea of like presence and like, having things feel like they're actually there is super important, and sound has a lot to do with that, like spatial audio, like talking to a person, hearing them talk. Yeah.
Well, Gio, we know that not all mixed reality experiences have to necessarily involve computer graphics and expensive headsets that process all that information. Could you share some examples with us of audio-only based augmented reality experiences or concepts?
Yeah, absolutely. I think this topic is something that often isn't really talked about so much because it's not, for lack of a better term, like as sexy and as visible, like no pun intended, as everything else that's going on. But like there's a lot of audio-only experiences that are problems that we can solve now. We're not waiting on any additional technology to catch up or any kind of form factor to catch up with a user. So like I think there's kind of two areas that I'd want to highlight on in talking about audio-only augmented or mixed reality experiences. And the first is thinking about experiences or applications that we already use, that we're already familiar with maybe in our day-to-day lives, that we can either improve or make easier or make more natural by actually making them an audio-only experience. So something simple like that we all do maybe every day at work would be conference calls, right? And the more and more I'm talking with my colleagues around the world, I get so frustrated with hearing, 5 or 6 or maybe dozens of different people all through the same channel in the same space, competing for air, really. And so simple things like audio-only conference calls that are spatialized, so that even if I am remotely talking to a bunch of colleagues of mine, they each have their respective spatialized position that I hear, and we're all within the same kind of either virtual, maybe virtual acoustic environment. And it's more of a natural way to actually engage with people remotely. I think that's like a very common thing or a common example that people bring up. But if you take it one step further, I think that audio only, thinking about how we can improve phone calls even in this kind of a vein. Like I was recently visiting Switzerland for work. We have an office over there in Zurich, and my colleague took me to this festival, this kind of winter to spring carnival festival that happens every year. It's been happening for 1,000 years, and it was really cool. The reason I bring it up is because it's just this total cacophony of flutes and drums and just sonic madness early in the morning. And I really wanted to share this experience with my partner back home, by giving them a call. And I was thinking, how cool would it be if I could actually render that person's voice in my environment and also pass, binaurally the actual immersive or 3D audio experience of me being in that space without having to worry about noise or signals contending with each other. So I think those are kind of general ideas where these are experiences that we have every day, things like phone calls, navigation, that could be improved with audio-only experiences. For instance, if I'm walking through that city in Switzerland, not having to look at my screen and be distracted by a little dotted line that I'm following, but actually being led, naturally by a kind of spatialized marker and being able to focus on what I see. I think that's right for the picking, and those are things that we can tackle now. But looking more into the future, what I'm really excited about is audio-only mixed or augmented reality experiences where we're actually changing what people are hearing in real life. So that could be like smart and connected listening. So maybe, we're at dinner and I'm maybe having dinner with my grandmother who's hard of hearing. I could maybe improve her hearing or audibility and focus in on her voice over all the walla walla that's happening around me. Perhaps if a baby goes crying behind, I can actually selectively take that noise and remove it from my listening experience. Like, that's just starting to scratch the surface of what I think is possible when we start thinking about, like, what if we mess with the actual signals that are going into our ears, and how can we open those doors? Yeah.
Guys?
Yeah, so I think that's super important. Something that AR is like the most important part about the medium is that context is like one of the biggest storytellers and element. It's like when you see a two-dimensional film or a production, like the context is like you have a certain set of ideas you're going into it with. Like, I'm going to sit down, I'm going to watch a screen. With like an augmented reality experience, you could be like in your bedroom, and everyone's bedroom is different. So, how do different sounds interact with different spaces, and,
But also, I think now with augmented reality, sound is more important than it has been so far, because when you see an experience, what makes it feel real is the sound. It makes a huge difference if you interact with an object or with something and it kind of feels a bit off. So I think that's a good opportunity now for sound, and it's very interesting, and that's why it's great to be that space. And how can we all work together to kind of improve sound and interaction with sound and make it more realistic for the experience, to make everything more realistic and make it more immersive. With virtual reality, you're in an enclosed space, so it's a bit different, but there's still challenges. But with augmented reality, where it's a blend between reality and the virtual world, sound is critical. So it's a very interesting space. Yeah.
Staying with you guys just for a moment, Orfeas, what kind of tools are essential for modern mixed reality content developer, sound designer, in order to deliver high standard audio?
So to design sound for this media, I guess you would start from the fundamentals. So you need a digital audio workstation to kind of start designing different effects. And then you would need an engine that's like an audio middleware to kind of make it work with the experience with the game. So like Wise or F-Mode. And we have different tools that allow you to design sound very quickly and very easily. You can also record your own sounds. The other thing that's very important is specialization. So you need to use an engine to specialize the sound and make sure that it works well with the environment. So there are different tools for that. Wise, they have their own engine. Oculus, Facebook 360 as well. DRVR, so different tools that you would use to specialize sound. And also, of course, you have to record the sounds, make sure that they sound realistic, place them into the environment. But what we are interested in is how we can make that even more realistic. And because with fixed samples, sometimes things could be repetitive. It's very difficult to design a sound for an object. But when you interact with this object in all these different ways, it might sound fake or repetitive. So we need to really work into making it more realistic. But there's a lot of tools that people use to create sound. It's a very creative process and very interesting. Yeah.
Let's put it into even more specific context for the moment. Jack, what kind of tools do you use in everyday life, and kind of tools that you can't live without?
Okay, so Unity is probably the most essential tool I've used at this point, because that's what our projects are developed in. It's a gaming engine. And it essentially is a bunch of built-in things for audio. Like you can place game objects in space and set the reverb zone, and set how they sound and like how it sounds if you're like looking over here versus over here using the Magic Leap, or any other device like that. Similarly, I work a lot in Pro Tools, and there's a lot of good integration with Pro Tools and spatial sound. I know for 360 video, there's like ambisonic pads and stuff, and if we're talking like bare essential tools, I'd say if you're not working with Unity or like a live rendering game engine, Pro Tools and the Ambiosonic package was my go-to.
Sounds like there's a lot to consider and a lot of choice as well.
Yeah, it's a complicated kind of workflow as well. Yeah.
Yeah. Well, hopefully we'll be able to dive into a little bit deeper into that aspect as well in a minute. Jack, staying with you, what type of creative strategies for audio, for mixed reality, augmented reality, have you explored or applied in your line of work so far?
Right. So in augmented reality, you know, there are certain points where, like, you know, you can't just like make an arrow and have somebody like look over here, or like, you know, or like let's say there's a bunch audibly happening. Like there are a bunch of like augmented holograms of people talking in a room. Like how do you make them listen to the part you want to listen to? There are things like this where, like, you know, blending in like kind of diegetic spatialization with like non-diegetic, more creative spatialization. Like, you know, everyone has their voice coming out of their mouth, but all of a sudden, like this person's voice, like you start hearing like in stereo in your two ears, or like, you know, you get like super close, like you would hear them in your right ear for something. We've experimented a lot with audio cues. Also, since I'm using Unity a lot, there's stuff like visually, like audio reactive visuals, like instead of like going and sitting down, like having like an effect or an animation, you know, that you sit down to like, oh, how does this animation sound? I sometimes work, because I do some of the animation too, like sound first, like create a sound and then have the actual visuals themselves, like a particle system, like reacting. Like how do you make it's an abstract object look like it's talking or look like sounds coming through it? Well, like, you know, you make the visuals react to the sound, so that it is, in a sense, like that is what it looks like when it's talking. You set the parameters. Things like, you know, like ASMR is like possible now, like, or like live kind of like ASMR sounding things with the Sennheiser AR1s. They're great. They do. You can blend in room sound essentially. There's a demo of it upstairs, I'm pretty sure, but that's something very cool and real that you can do. Is like, you know, you can choose how much of like sounds you want from the outside world. Like if there's like people talking in the room, you could hear them, and if like, you know, you want it to be closed off, you can lower that volume. It's basically just, there's a large toolkit right now for what you want to be heard and like what you hear, what it's telling you to do.
Thank you. Jean-Marc, Geo, Orfeas, you guys essentially represent companies that create tools for content creators and sound designers, etc. Can we talk a little bit about the process of informing your kind of decisions that you use in the development process? How do you know we need to focus on this or the other? I would love to hear more about that process internally.
Okay, so starting, what we're involved in my team at Magic Leap is the core technology to render the experience. So just like you need some algorithms to render the graphics on those. So those devices, for those who don't know, they look like goggles. You can see through the lenses, but the device can project images on the lenses so that they appear to be there in the world that you see. And the technology we develop is the audio counterpart of that, so that what you see also can make some sound, and that sound appears to come from what you see, from the objects that you see. So for us, the challenge is fundamentally a 3D audio technology challenge. It's our signal processing algorithms, but we want to expose them, make them available to the users in such a way that the perception is the most important, because we know people who are going to use them are sound designers. So the underlying effort is to focus on what's most critical perceptually. Given that this is a device that's going to run on batteries, we're going to have to save power and minimize heat, etc. So we try to make the algorithms as efficient as possible, at the same time without sacrificing what's perceptually most critical. So we're really at the bottom of the stack, where these are algorithms that are just to output the sounds that are right for the experience, and we make them available through an SDK. Essentially through plugins for Unity, Unreal, etc. as well as an internal game engine. Or I should be maybe holding this closer. So that the developers like Geo, like Jack, can then use that technology in a manner that's optimal for the particular device that we've developed.
How about you, Gio?
Yeah, I mean, similarly, obviously Sennheiser has a long history of hardware devices, both on the capture and the playback side of things, and also, for that matter, kind of split between like pro-focusing solutions or prosumer solutions and normal day-to-day people with consumer products. And so, I mean, similarly to how Jean-Marc just finished, like, it really just depends on what solution we're trying to solve and what user we're trying to serve. So specifically in a mixed reality context, like, we've done solutions before thinking about how can we bring binaural or 3D audio to normal day-to-day people, maybe people that are doing blogs. And so we made the AMBEO Smart Headset, which is something that you can just plug into an iOS device, and that was something that required a lot of direct communication just with normal people that were making videos for YouTube and things like that. But coming back to us specifically for mixed reality and Magic Leap, obviously it's a big kind of wild, wild west space. And there's so many things that haven't been defined yet, and there's still a lot of content that I think needs to be made for experiences for people to have when that universe is ready for everyone, no matter who you are or where you are. So the focus for us primarily has been thinking, like, how can we assist those developers? How can we make sure that they're getting, the best tools that they need to either maybe capture content with things like the VR mic and working together with those people, or on the playback side, like the AR1s are kind of our solution for the Magic Leap specifically for a dedicated playback headphone. And so it really just matters, what user you're focusing on, what solution you're trying to solve, and making sure that every change you're making to a product and everything looking forward is you're always keeping that, keeping the user's experience and their needs in mind. Yeah.
Yeah, for us, our mission is to improve the way people work with sound. So initially we started with like Dehumanizer, which allows you to make monster creature sounds using your voice. So we focused on like something that takes a lot of time, and it's a kind of a complex procedure. So for that example, you need to use multiple effects and different animal sounds. So what we do is we simplify the workflow. So we put everything in one place so you can perform the sounds with your voice, for example, Dehumanizer. So the same with Weaponizer for design weapon sounds, with Igniter for vehicle sounds. Again, very, very complex workflows that take hours. So we kind of analyze how people design sound and how we can make that easier, faster, and reduce the time that it takes to design something that you have in your mind to make it happen. Because when you say, oh, I want to create this sound that sounds like that, you can think about it, you can have in your head how it's going to sound, but then to create it, you have to use different tools, you have to edit a lot, you use a keyboard and mouse. So what we're trying to do is kind of make it faster so you don't have to use a keyboard and a mouse that much, so you can perform the sounds. And that's how we came up with Reform as well, which you can perform any sound effect with your voice or any other input. And then a step further is we can do that automatically based on different experiences. So we really study how people design sound and what are the pain points and how we can improve that. We work as a team, and we work with the top professionals in the industry to make that happen.
Gio, you've already mentioned a couple of pieces of technology that Sennheiser develops, but can we just go a little bit deeper into that? And I wanted to ask if you could give us an overview of what types of hardware and software tools have you and the AMBEO team at Sennheiser have been developing to break those initial barriers, essentially, and enable content creators and sound designers to kind of take it on next level and essentially kind of democratize the whole ecosystem between creation and content consumption.
Yeah, definitely. I mean, I think that one thing specifically in the mixed reality space that we identified really early on was that there was a need for a dedicated mixed reality playback device because, Magic Leap, as well as if you look at HoloLens or even some of the VR headsets and solutions on the market, a lot of them have built-in speakers, which obviously is something necessary for the product to have it working out of the box. But you may find that you need a broader frequency range to reproduce for your listener, or maybe you need to ensure that you have privacy and there's no bleed between you and other players or you and other people. And so we started identifying those needs, particularly for developers, and saying, okay, we have the tools to solve that. And so that was kind of the result of the AR1. Really, that's what that resulted in. And that's, for those that don't know, is like I said before, kind of our dedicated playback device for the Magic Leap, where you can plug it right into the LightPack computer, and each earphone, it looks like a normal pair of earbuds, but there's actually a dedicated microphone, so a binaural stereo microphone in total, in both ears. And so what that allows you to do, which is super important when it comes to mixed reality, is activate what we call transparent hearing, which is this idea that I can let in the sounds of the real world around me just as if I wasn't wearing a pair of headphones at all. And then I can then take that reality layer as a bed and augment that essentially with these virtually rendered sources, with binaural panning tools and things like this. So, on the hardware side, like these headphones that utilize transparent hearing and really embrace the reality part of augmented or mixed reality has been a focus for us. And then when it comes to the software side too, it's a matter of kind of identifying what needs that we found engineers finding themselves in and having to solve, and particularly within the mixed reality space, like on the Magic Leap platform, where there's so many developers right now and not necessarily consumers using the product just yet. We wanted to make sure that in addition to providing a hardware solution, we could give, in software an example of what we see as possible if we're really pushing audio in this medium. And that's why we made this experience called the AMBEO Augmented Audio Lab for the Magic Leap, which is really kind of this fun way of interacting with sound as if it was a physical object. You can create it, destroy it, shape it, manipulate it, throw it around the room as if it was like a ball of energy, essentially. And we really wanted to kind of pose the question to the development community at large, because it is still so ill-defined of what can be done in this space. We wanted to ask, if sound was something that you can really interact with or manipulate as a real object, or for that matter, if you really focus in general on sound as the heart of a mixed reality experience, what could be possible? So yeah, ultimately just both on the hardware and software side, trying to make sure that we're giving developers and creators every tool that they need to push these kinds of experiences forward, I guess.
Jean-Marc, your team at Magic Leap have also developed a number of integrated tools that essentially streamline the sound production process within Magic Leap's own operating system, Lumen, but also widely used game engines such as Unity and Unreal. Could you talk a little bit more about Magic Sound Field Audio MSA plugin, which I believe does a lot of things? I'm going to have to read it out. Involves the key functionalities for spatial audio, including object-based spatial rendering, OpenAL Reverberation engine, near-field binaural rendering, physics-based distance attenuation, and perceptual room modeling, a lot of things. Can you go one by one through these features and explain to us why they're essential?
Yeah. So the fundamental one that's needed first is to be able to place the sound in space. So that's the 3D positional audio rendering. And that's necessary because when we display, so again, we're talking about a mixed reality device where we can see the real world, and there are objects that are presented to the person, to the user. And they need, as you see them, the sound needs to come from where you see them. And if you no longer look at them, the sound still it's necessary for the sound to still appear to where it was when you were able to see the object. So there's a critical piece of the technology, which is the 3D positional audio rendering. And as I mentioned earlier, it needs to be running in a very efficient, computationally efficient way. So then the refinement, the next refinement of that is it needs to also, we need to be able to render the position in elevation also, in case, like if you bend down or so that the object seems to be relatively to your head to be above. If you walk towards an object, it needs to sound as if it's now much closer to you. So there are some special processing that's necessary. That's what we call the near field rendering. then what needs to happen is if the object turns around, like for instance, if the object is a character, so in that case not an object, let's say a person speaking, but looking away, the sound of that voice is going to change. And so it's going to be noticeable if we don't reproduce the impression that this creates. So we need to simulate what we call the directivity of a source. We need to take into account in the virtual world how it's oriented relative to the person. So that's another piece of the technology that we have to implement in there. And then perhaps finally, I'll add the sound of the room. So in virtual reality and game audio in general, that was always critical to add reverberation. So that in the very early years, like in the late 90s, reverberation was missing in game engines. And it was obvious that it was necessary to add that. So if the game happens in a cave and you don't render the sound of the cave, it's not convincing at all. Very frustrating. In mixed reality, something special happens because when the sound in our environment emit some energy, that energy bounces on the walls of the environment, and we call this phenomenon reverberation. And if then we, at the same time or just after, we play a virtual sound object, and we use the same kind of techniques of using a virtual reverberation from any effect that may be available to the programmer, if it doesn't match the acoustics of the room, then there is what we could call a dissonance between the real world that you can hear, like if somebody who's really there is talking to you, and then if you say you want to simulate a virtual conference, and there's another character which is a virtual person, but their voice resonates in a space appears to resonate in a space like that's not yours, then we are missing something. So we have an extra challenge, which is to be able to simulate the sound sources as if they were in the space you're in, the user is in. So we had to design the engine in such a way that if you tell it enough information about some general characteristics of the reverberation of the room, it'll automatically make the scene sound as if the way it would sound if the sources were at the position they are, oriented the way they are with the directivity pattern that they have. So that was probably the biggest challenge, the biggest innovation we had to introduce in the design of the engine. So that's the fundamental algorithm, and then we expose it through those tools that the game community is very familiar with. So essentially we created interfaces for Unity, for Unreal, as I mentioned earlier. And those same parameters show up. The room reverberation, XYZ positions of sound sources, their orientation, the directivity. It's the same model in all the engines. We just provide a front-end graphic UI for sound designers to use those. So that's essentially what we call Magic Leap Sound Field Audio right now, focusing on spatial audio rendering, and then as things move forward, we'll end up also having to worry about how we generate the raw material of the sound. That's the sound synthesis is going to become a critical piece of that. And a number of things will extend this Magic Leap Sound Field Audio technology.
Yeah, I think another great example of that, taking the room modeling one step further, is simple things like, if I have a sound source or a person talking to me and I place them in another room behind the wall and I close the door, right? Like simple things like occlusion that maybe we take for granted because they're kind of implicitly built into virtual reality experiences. But now I think that really hits on the heart of what sets mixed reality audio apart, is that you have to be, consciously aware of your context, and it has to be working well within an arbitrary environment, which is, I think, the really exciting thing about mixed reality audio.
I should probably add that, is that in mixed reality, you don't know in advance what the world is around. So typically when you program a mixed reality experience, there's a collection of sound sources, and either they've been set in space, their relative positions have been decided in advance, or it's decided at the last minute depending on the actions of the experience, like maybe the game scenario. But in virtual reality, the room in which this happens and its properties and the rest of the scene is known in advance. It's programmed by the person who created the experience. But in mixed reality, that person does not know in advance what the room's going to look like. Is there going to be furniture? If there is some furniture, is it made of wood or metal? And so all these parameters are discovered at the last minute during rendering time, and that makes mixed reality completely different, fundamentally from a technology point of view, when compared to virtual reality.
Yeah, and it's definitely something that you consider when you're developing one of these, is like, you know, to create like the presence of the room. We've done things like, you know, like, oh, your mom just got home. You're playing like a character who's like in it, and then like, you know, you just put subtle, quiet, like low-end footsteps in the background. Like, you know, like somebody's in the house. It's like giving a presence. Like you may not notice it. Like you add like artificial air conditioner sound. You know, it's like maybe it's a hot day or something. Like you place the sound up there to make it sound like, you know, you're creating a context audibly that you can't necessarily have control over within your space. So you can do other subtle tricks with audio like that.
Well, we just talked about quite a number of really cool features that are available as a part of a kind of modern pipeline audio production for mixed reality, and sounds like it's absolutely critical to have those in place. Otherwise, you simply cannot portray the realistic wherever the content is, essentially. But so there are many technological achievements in general that we can celebrate as an industry in this field, but we do still face some challenges as well and some limitations. Things such as computational power for object rendering and elevation perception, etc., and or even perhaps like, you know, simple necessity of having to implement pre-rendered material that you produce, design, and endure before you move on to audio implementation game engine. So Orfeas, I would like to ask you, and actually I would love to ask all of you, this next question is whether or not we might expect new developments in the field of procedural audio and convolution, particularly in your case, as well as the integration of these tools within the pipeline that essentially involves real-time rendering. And to be more precise, for example, I'd like to find out more about physical object with a digital object kind of relationship, and what you might call physics-driven sound synthesis, or procedural audio as a more commonly known term.
Yeah, so when you design a sound for a game, usually you have to, you know, record different sounds and then say, okay, if I interact with this object this way, play the first sound or the second sound, the third sound. So you have different kind of sounds that play in different interactions. But in mixed reality environment and in even virtual reality, you want the object to feel more real. And because you see the object in front of you, it depends on how you interact with this object. It needs to sound different and sound more realistic. So procedural audio is when you generate sound from using synthesis or from scratch. So using like physics models and things like that to, and based on the properties and the material of the object, generate the sound automatically. Which is kind of challenging at the moment. I mean, there are different techniques that people use, but a lot of these things using just synthesis, most things don't sound that real. So it's a challenge, and there's a lot of work that we're doing in that field. And we basically, what we are trying to do is use samples for that. So it's kind of a mix between procedural audio and sample-based procedural audio, let's say, which means that, you know, you record the sound of, you know, a cup, for example, and different, how you do interact with this cup, and you make different recordings of that, and then we parameterize that, and then basically you can reproduce that in real time, but it's very dynamic. So it's more like procedural audio, but using existing recordings, which makes it sound more realistic. The other challenge with procedural audio is that you need someone very experienced to design the model. So if you want to design an instrument, for example, it's extremely complicated to using physics to create a model that create any possible sound that you can create with that this instrument can make. So it's a very challenging field, and it's very interesting for us to develop and be that space.
So I'm curious whether tools like Reformer could potentially become part of kind of a real-time rendering pipeline. You know, in like somewhere like maybe a part of MSA system that could essentially help with some of those challenges. Do you have anything to add on that?
Yeah, I think the first thing probably worth mentioning is that even if we have the best possible 3D audio rendering algorithms, if the material that up front of that we play some material that we're going to then position in space, and if that's not realistic, we can do a really good job rendering 3D audio and positioning them in space and simulating the acoustics of the room. But if the sound is repetitive or not realistic, given the particular conditions, like maybe a cup hitting a wooden table but sounding like maybe plastic table instead, immediately that's going to break again, create a dissonance between what you expected and what you hear. So we are well aware that that's going to be a major next phase, really, for us. So what we call MSA, Magic Leap Spatial Audio, or Sound Field Audio, needs to incorporate that. Now, I guess that's probably where I should stop in answering this question, to give a chance to others to contribute to this discussion.
Yeah, is there anything more? I mean, yeah, exactly. It's a very interesting topic, and it's something that a lot of games have, procedural audio, but it's usually a small percentage of sound. So you can do like the sound of air conditioning, because it's like noise and it's repetitive, or bird sounds, or maybe water. But if you have more complicated sounds like surfaces or animals and things like that the sounds are very complicated, are very difficult to create them from scratch. So that's why kind of what we're looking at is using samples to create that in real time.
Not to get too futuristic here, but I'm wondering if machine learning has a role to play at some point in this business by using its powers to kind of learn all the complex patterns and be able to kind of eventually reproduce those things and really help us to streamline the workflow.
Exactly, that's what we're looking at, and we've used some machine learning for Reformer, the way we analyze the sound. So we have a sound library and we analyze it, we get different characteristics, and then we reconstruct the sound in real time based on data or sound. So yeah, machine learning is something that is key to understand sound and all the different properties in order to reproduce that in a realistic way.
Could you open the curtain a tiny bit for us and tell us a little bit how it works?
Okay, so it works as, let's say you want to create the sound of, let's say, a tiger, and you want to be able to perform that. We just have different recordings of tigers, different growls, different breathing sounds and things like that. And then we analyze that, we make a table, let's say, with all the characteristics of the sound, different peaks, different frequencies, and a lot of other things. And then when you make a growl into the microphone, we analyze that sound and we find parts in this library that match with the properties of your voice. And we construct a new sound effect in real time. The same with materials. We have, let's say, you want to make a leather library. So then, you have footsteps and you want to make it sound like you were in leather shoes. So we record leather and we make different expressions. We get a Foley artist to make different sounds with a leather jacket, for example. And then we take that and we analyze it and we create a leather library. So then you can perform it with any kind of sound. You can rub the microphone, for example, on top of the microphone, make sounds so the microphone then will sound like leather. And because it's real time, let's say, sound editing and different sounds blend together that are exist in the realistic, it sounds very, very good. So that's kind of how it works.
Very interesting. Jack, as a content creator, what technological advancements you have been oops. Apologies. Let me start again. As a content creator, what technological advancements you've been enjoying thus far, especially this stuff we touched on earlier, and perhaps are there any challenges that you're facing and you kind of features you would like to request? Because you're sitting here in front of people who essentially develop the cutting edge technology. Like, what's the most you know, the most common thing that you tend to come across on a regular basis?
Okay, yeah. So in terms of, I'll start with the good. In terms of things I enjoyed, yeah. In terms of things I enjoy, I think our most recent project, A Jester's Tale, was on Magic Leap, and it's been incredible working with that and pairing with the AR1s, which we didn't end up using at Sundance itself, but experimenting with has been great. You know, it's just cool thinking about sound in this new way when you're mixing for something that can react to like your own physical position. It's no longer like, you know, trying to mix for like a 2D thing and like you have it in quad and you can make things kind of sound like where they are. Like if you're like looking straight forward, like now, you know, you can be like in a room and like, you know, no matter where you are, like, oh, that's there, you know, that's literally right there. There's a person in this room with me. I can see them, I can hear them. Like if I turn away, you know, it's in my ear right here, like very humanistic vocals and stuff. I haven't gotten a chance to work with Krotos yet, but having seen it now, I'm very excited for the future of where that'll go. Yeah. Yeah, and just like the implications for that, not just like things like sound design, but for music, like working with music inside Magic Leap has been a joy. You know, you can make, you know, beats and stuff of just like movement, like physically moving beats, like, you know, work that doesn't, it's not like a stagnant stereo song. Just like as a compositional tool has been really interesting and very impressive to work with. And like, you know, if you've done the demo upstairs for the Ambiosonic thing, like you can like place sounds behind like a desk or something and it sounds like it's over there, like, you know, new strategies for how to like compose and like generate and create music has been super interesting. In terms of challenges, it mainly comes along with mobile AR, I think, is where we were talking about how, like, you know, if you're in a headset, like it's reacting to where you are, while like if you're using like a mobile like device like an iPad or an iPhone, you're trying to get the spatial audio going. You know, it's less accurate. It's more like you're walking around holding like a boom or something, where you can get like cause some interesting effects and like do stuff, but it's always going to be like you're holding like a camcorder type thing instead of like, you know, you're immersed. It's less immersive. I think that would be a really interesting project, or like an interesting obstacle to overcome, is how to keep the same level of like headset immersion in the audio with like a mobile device. I know Gio was saying that there's some things they can do with like general face tracking, so like it's like while you're looking forward, like it's tracking your face and it can see like, oh, you're turning this way, like slightly like up the signal on the right ear and stuff like that, which is, I think, a start and like a really good creative solution. But seeing as currently the Magic Leap's not as readily available and mobile AR is kind of the most distributable form of the medium at this point, that's an interesting boundary to overcome for the spatial sound designer.
Before we wrap up and open for Q&A, I just wanted to, I suppose, ask your conclusive thoughts about the whole industry. And I suppose you can mention a few things. Perhaps if you're feeling ambitious, maybe you could talk to us with some upcoming trends or things you anticipate, or maybe just share your thoughts about where do you think industry is heading, or where it should be heading and it's not. Anything you like. Jack?
Yeah, I think the future moving forward, I think something that really interests me personally and like I think could be popular is more generative like albums, like generative mixes. Like, how does this song sound at night? You know, how does this song sound, you know? Like it's like we have it right now with like AR, where like it's a different experience per each person's context. But like if you just apply that to just the sonic world, like, you know, it's like you could be listening to an album and then like it's generating, like taking in, like, you know, maybe like it's hooked up to like something with photoresistors where it's like it can tell it's light outside or like the time of day, and like how it's constantly evolving and like less of like a stagnant piece of like music or sound art, but evolving with the user.
Yeah, exactly. I think interactivity is the key, and it's a good really time for sound. And A lot of the time sound is an afterthought because people focus a lot on the image, especially when it comes to like, you know, films and even games sometimes. But now I think with augmented reality and mixed reality we're in a very exciting time because sound is very important, and I think the future of sound is more interactive, more generative, and more performative. So you can perform sound, you can interact with sound, you can generate sound. Also, it doesn't have to be fixed media. It could be, you know, things that change based on different parameters. So it's a very exciting time, and all these technologies, AR, machine learning and artificial intelligence can also improve kind of how we work with sound and how we perform sound. So it's a very exciting time. And also the other thing that I think it's going to affect that, and not only for sound, but in general, is 5G, something that that I've heard a lot of people talking about, because 5G will allow information to kind of be transmitted way faster, which means that we can have a lot of processing power on supercomputers, and then we can stream anything on mobile devices. And that's something that could also help with like generating sound, a very complex sound in one very supercomputer. Then you can stream that using a mobile device. So
yeah, I think you both hit on like one of the things that I'm really, really excited about, which is just non-linear experiences. Yeah. Like especially for music, because I'm a musician kind of as my night job, and like the idea that you can create a piece of music that is different every time, or like you said, like evolves and is responsive to not just maybe the time of day, but like the weather or how you're feeling, like your heart rate, and like really getting into thinking about what can the future of, you know, music or just in general like entertainment experiences can be, because I think we're also going to start to see that the hard lines that in traditional media have separated music from film, from video games, are starting to become more and more blurred in this kind of a medium. And so like I feel like there's so much space to have, you know, an interactive music video that's kind of a game but kind of not. So I definitely like sympathize with that feeling. And the other idea that I wanted to throw out there that I'm also really excited for is just the generally shared experiences in mixed reality, whether they're local and I'm, you know, interacting with the same pseudo virtual real world with people in the same room, or it's remote, or maybe a combination thereof where it's like multiple people around the world having a shared experience. I think that's going to be really, really cool. And if you apply it to like music or games, you know, like what could the future of concert experiences be like when all of a sudden you have a level of interactivity that was never possible before in a traditional concert venue, and you know, you can have it within the privacy of your own space, or maybe for that matter, like, you know, I think we often, when we think about mixed reality, we're like defaulting to the environment of being in your living room with your personal device, but like that's totally not always the case, right? Like, you know, this phrase got thrown around a lot with VR, like the VR-cade, where people were thinking, oh, like we're gonna go to VR-cades again, and people are gonna go to the arcade to have these like amazing, you know, like shared experiences that are installations specifically, like what installations could be like, where we're thinking about more than just the living room environment. Like I think there's a totally untapped space that's just waiting to be kind of cracked open.
I think we're going to see near term. There's going to be probably a push coming from enterprise kind of applications, especially I think virtual meetings. One of the things that is a hassle for our life as professionals is that we have to travel for a meeting, and we use a lot of energy and time for that. And as these technologies evolve, one of the things I think we can expect is that it'll become practical to have meetings, virtual meetings, without having to travel. So that's one of the exciting utilitarian things. It's actually a shared experience, as we mentioned, but I think, of course, I believe there's so much demand for being able to do this for professional applications that it's going to be a pool for those technologies. But then the rest is all the new capabilities for entertainment and creative applications that I think essentially we come into a world where we're used to going somewhere. In fact, there's this dichotomy between the you are there experience, where you go somewhere, like you go into a movie, you go into a concert, so you you try to move from your reality to experience something new. But I think we're going to end up with more experiences and expect more experiences where art is presenting to us where we are. Like, for instance, the concept of an installation where you don't go to see the installation, which is what we do now. You don't go to a museum, but the art comes to where you are. And you pick what your experience is going to be without you being limited by your ability to go to a place. So I think that's the other part of this telepresence in a trend and development that's happening in our world today.
And I think it's a good time to open the floor for questions. Over to you guys. Yeah, maybe if you want to raise your hands, and then somebody will come up to you and pass the mic.
You mentioned that when you create a virtual object or a virtual creature, the acoustic properties of this creature have to match the acoustic properties of your room. And I can see that it's kind of a holy grail to reach, to make an experience believable or feel real in that sense. But I can see that we could take that further at that point, at some point, and create a new reality that has its own set of laws of physics. For example, out of the top of my head, an alien creature that does not speak by resonating vocal cords, but that speaks by using the glass of water on your table and emanating sound waves from there, for example, or even having a way of an experience of hijacking your senses by changing the room acoustics completely, and suddenly making you feel that you're in a different room, and with additional visual cues, making this believable again if it's done right. I just wanted to hear your take on this. What you think are the possibilities and challenges if we go one step further?
So just to some ideas. I think it's a very exciting possibility that we could use these techniques to even change the sound of what's physically here. I've only talked about matching the physics with sounds that we add artificially, where we could call them digital objects. But then there's the other part of it, which is to take what's there, like you talking to us, but what if we could make you sound, like a person of another age or another gender or an animal, so that's replacing the physical sounds. To some extent, we have to be able to do things like that, because if we create an experience where there's a physical character or sound object, and we put a virtual barrier, say a virtual couch. There are some demos that you can see now where somebody goes and you go online and you can pick a piece of furniture that you would like to put in your room. And you can see what your room would look like, and then maybe you decide whether you buy it or not. But what if your dog is on the other side of that chair? And well, you don't really care because you want to just see what the chair would look like. But what if we had experiences where, in fact, we would like it to sound as if this chair is really here in the room, and then we would have to select the sound of that dog and make it sound like it's more muffled because it's behind the object. So that's just a very simple example, but then we could make it sound like a bigger dog, or so. That's also a possibility it's going to become possible. It's more complicated because then we have to actually selectively extract pieces of the sound environment and modify them without modifying the rest. So it's going to happen just because we have this problem with the obstacles, the virtual obstacles. We're going to have to fix this problem, and that'll give us the ability to do other things, like virtual modifications of the physical world.
Yeah, I think that also makes me think of, like, I've seen so many, World War II Call of Duty type games where a grenade will be thrown and it'll go off, and then all of a sudden you'll have this explosion and then a really high tinnitus ring, right? And it's like a really cool effect because like all the audio from your TV or whatever is being filtered as if, you know, you've just suffered temporary hearing loss. But like the cool thing about a mixed reality playback device is that, you know, if you're using headphones that have microphones embedded in them, like now you have the opportunity to actually take it one step further and then apply that kind of a filter on the person's real world hearing. And so like I think that touches on, there's a lot of potential for like giving developers and creators control over the person's real world hearing and adjusting that too. I mean, we in the past have an ongoing kind of developers program with people that are working in the augmented and mixed reality space. And one of the really cool applications that came out of that program as a result was kind of almost an empathy application where you could listen through the ears of someone that was suffering from tinnitus or like severe hearing loss. And so I could hear the same way that grandma's hearing and have an idea of what that's like. And I don't know, that's, again, just kind of scratching the surface of that, but I think it's really cool.
Yeah, and with the transparent hearing, that's one of the things that is very interesting for us, because we can use kind of, we're talking about Reformer, to kind of transform someone who is talking to, you know, a completely different creature or an animal, or you can change, you know, when you walk on a surface and then the surface changes to becoming like plastic or wood. You can do that in real time, and if you have transparent hearing, you can hear some of the signal that the microphones pick up, but add on top of that, you know, different kind of sounds that make the experience more immersive. Yeah.
Yeah. I think that's a really interesting thing about the AR ones with their real world, like including the possibilities for that on like music could be anywhere from like, if you know, like side chaining is like side chaining real world stuff, or like potentially recording in objects, like back to the generative music thing, like taking in audio input from your world and somehow incorporating it into the music. You know, as long as we're talking about generative, like how do you immerse somebody when you're just working with sound? And then, you know, there's all types of other possibilities, like, you know, if you have enough control over the space, like if you're doing like a location-based exhibit kind of thing, like things like scene changes, like you could like just like, you know, oh, now I'm outside kind of thing, like, you know, by changing the reverb, like there was like some room verb, like if you're using voice interactivity, how you perceive your own voice, like kind of like how the effects are applied to that with audio input and things like that. Like, oh, I'm noticing now when I talk, I'm not hearing like this like big like cathedral reverb now, it's like a lot more dry. You know, changing like you as a character using the AR in the experience, changing your perception of your own space and your own context, I think is a really powerful tool to be included.
Any more questions, Guy?
Got one. So I know earlier you guys kind of touched on how this can be taken into, like AR can be taken into like events, and actually instead of coming to the user's living room, they're actually going out to somewhere to experience this with many people. And then as well as mixing that with music. So like with music events, how can maybe like AR be affiliated either with like a festival or a club where people can still get together, but you don't need as large of a space or like a big lot and all of these like scaffoldings to get a large event going, but yet you can put these goggles on and now have all of that already there through AR. Like, what's the future of that looking like?
Okay, so yeah, so in terms of that, usually what we've worked with so far has been what we call LBEs, location-based exhibits. So like in regards to like you go to a thing, and that's what it is, like you have more control over the situation. You could design an experience like you were talking about, this like an AR concert. But I think what's also interesting about AR, like aside from the audio, is like there have been like apps you download when you go to a concert, you know, and then if you like look at the concert like through like your mobile device or stuff, like, you know, the visuals themselves are like, you know, audio reactive to like what's happening in the concert, and like, you know, you can like look at other people using the app in the crowd, and you know, things like, you know, an AR silent disco I think could be like a pretty cool idea, you know, like everyone wearing their headphones and like generating like, you know, some kind of data. in terms of the future of artistic expression in like LBEs, like gatherings that have to do with augmented reality, taking like crowd data and like applying it to like a visual reactor like that is at a concert, for example.
You could imagine experiences where that are bi-directional, where the audience is actually, every concert is different because the audience influences what happens. And so that maybe no longer a stage, something a bit more like a club where everybody is together. And if you imagine, if it's an augmented reality experience, because it's possible to present things differently than what they are, the kind of enhancement or additions to the club experience could be can be very large. It can be adding characters who are not there. It can be adding objects that are not there. It can be making people hear different things. Instead of, even though everybody is together, if they have a personal listening experience, like on the AR1, they can all hear something a little different that matches what is better, maybe a better, that matches better their expectation, or what is more exciting to them. You know, everybody can have a slightly different experience, but it can still be shared. So yeah, these are all possibilities.
Yeah, like I think an example that just popped into my head is maybe you have one concert being broadcasted or like volumetrically shared from one specific location, but then depending on the country that you're experiencing that concert in, maybe the language is different, you know, or maybe if you're at like one specific location. I love the idea. I've always loved, like, I wanted to make this happen. Is like you go to a club and depending on where you are within that club, like what room you're in, what environment you're in, they're in, like the music actually changes. So maybe there's a certain mix of actually what's going on at the front of house, like, or like on stage, you know, you're in the main floor and it's a total banger. But then you go outside, like in the lounge area, and it's a slightly subtly different mix, and it changes depending on where you're moving. And if you go to the bathroom, maybe it's like an underwater version, I don't know, whatever. But taking your location and things like that into account, I mean, that's going to be super cool.
Do you have any more questions?
Yeah, so I had a lot of brilliant ideas and mostly entertainment based. Are there any, the virtual meeting, you were talking, Gio, about the walking through the city and being able to get your directions without looking down. Is there other sort of hands-free, industrial, real-world, not entertainment-based applications that you're working on or use?
Driving could be another one.
Yeah, like hands-free safety.
Yeah, operating machinery and kind of have warnings about different things for different directions.
Yeah, situational awareness, things that in your real world, things that you would normally not be aware of. Say, for instance, something that's visible but does not normally make a sound because it's too far from you, but you care about this information. So maybe an alert, danger, that you would not be aware of it because it's behind you.
Yeah.
But if we enhance the experience by making this a sound alert, then you have basically it's like a bionic experience. You're more than the person you are. You're able to be aware of things that normally would not know. So, for instance, if you're supposed to go to a place that's behind you, but there's some danger and so you should not turn around because you might fall into a hole or something. So ideally, we could have. It's possible to endow the person with the ability to avoid dangers that a human that does not have the technology with them would fall into. I think there's a general category of applications that is situational awareness, enhancing our ability to understand the world better, more quickly, discover things that we would not normally be aware of. So I would call those situational awareness. It's kind of a generalization of the navigation application, but it's not just entertainment. I think fundamentally you can imagine that technology is just enhancing the human.
Yeah. And augmented reality might replace mobile phones at some point in the future, so you don't have to look at your phone all the time, and you be like that. You have awareness of your environment, but it's enhanced environment. And sound is very important because you react to sound. So if there's a car and it makes a loud sound, you will just react to it, because we used to react to animals chasing us. So sound is very important because we react to it. So using that to kind of warn people and for directions as well, and kind of can enhance the experience and augment our reality.
Yeah, this reminds me of like a thought experiment that I sometimes like to do, which is like thinking about, okay, what's the problem that I have right now, and how am I using technology currently to solve that problem or ease that task, and how is that technology a barrier to my solution? So like, that's a little vague, but to give you a concrete example, like if I need to speak with someone that talks a different language than me, like this whole idea of real-time or pseudo-real-time translation, like you're using technology, but you don't have to work through a translation application. Like you're approaching an audio-only experience that gets rid of that barrier, so you can really kind of just grease the rails and make it a natural kind of an experience. So, I mean, even that specific example, like real-time translation, that's definitely one of those holy grail things, and there's a lot of work being done behind that, which is pretty exciting.
And just worth adding, I think we're just scratching the surface. It's really early days for mixed reality applications in general. If we look at what happened with virtual reality industry, gaming industry has traditionally been like an early adopter for all kinds of things of this nature, and now medical applications, education, training have become one of the biggest verticals in industry, and obviously the use of audio from like sort of creative and practical standpoint has become a critical part of that process as well. I think we're yet to see more examples. Do you have any more questions in the audience?
Are there any experiences or any content that you guys have encountered lately that you feel is pushing some sonic boundaries in any directions that you're excited about?
A Jester's Tale.
I still have to try it. It's going to happen at some point.
Yeah, it's fun.
Yeah. Jack, Orfeas, Gio, Jean-Marc, thank you so much for sharing our thoughts today. I also want to thank the amazing team at Sennheiser for organizing this panel. And just a couple of short announcements before you guys leave. Make sure you join us tomorrow and Saturday for the last 2 Game Audio podcast installments here at the store between 7 and 9 a.m. Pretty early. And also tomorrow is the last opportunity to come upstairs and check out the demos. There's a number of things that you can try out. That's between 12 and 2. And thanks again for coming along, and have a great evening.
Thanks, everyone.
Thank you.
Thank you.